Hello and welcome to a new video in which we shall discuss logs and exponentials. So the first law of logarithms says that a to the power of log base a b equals b. What does this mean? It says that a cancels log base a and we get b. This is very similar to when you have an equation like 3x equals 5, and in order to isolate the x, you divide both sides by 3. So the 3 cancels the 3. So because this relationship here is a multiplication relationship, we cancel the 3 by division. So we're dividing by 3. Another example is where you have x plus 7 equals 9. And to get rid of the 7, we subtract both sides by 7. So these cancel out, and you have x equals 9 minus 7, which is 2. So this idea of canceling using the reverse operation also applies to logarithms as well. And logarithms help us to solve the problem, for example, of 2 power x equals 3. Because 2 power x equals 4 is easy to solve. We should know that 2 power 2 equals 4, so x equals 2. This is easy. However, this is a difficult problem to solve, and we need logarithms for that. So how do we solve this problem? We should know that the base, this is called the base, and this is called the exponent. So this base here can be cancelled by introducing something called log and adding a base of 2 here, and then just putting any number that we want in this box. If you put 3 here, then the 2 would cancel the 2 in the log's base, and you would just have 3 surviving, in a sense. So let's apply this rule to these problems here. So if you have 3 power log base 3, 4, these would just cancel out and we would get 4 as an answer. So this here is 4. Let's try another problem. Here we have 6 and log base 6. So these cancel out and we get 5. So 5 is the correct answer here. Now, there is a special type of logarithm called ln. So ln8 is similar to log base e 8. So what is log base e? What is e? Similar to pi, so we have pi, which is 3.14 whatever. We have something called e, which is 2.73 decimals. Pi is a ratio of the circle, perimeter or circumference, and area. So pi is a constant that denotes the ratio between the circle's circumference and its area. It has applications that are related to circles and trigonometry. Similarly, E is a constant that models exponential growth. So this has applications in biology, for example, where you're modeling the growth of a population of bacteria, or just like humanity, population of a certain country. So E has a lot of applications in modeling, and it is equal to 2.73 and then other numbers, other decimal numbers that we are not really interested in right now. So the E is a number like any other number. And we have something called the natural logarithm. So ln x is the same as log base e x. So how would we get rid of the e in the base? By adding an e in the base as well. So how does that work? Let's first convert this to e power log base e 8. And now we have a base, a number, just like any other number. And we have a base in the logarithm. So we can just cancel these out and we get 8 as a final answer. So e power ln 8 is the same as e power log base e 8. And these cancel out and we are left with 8 as a final answer. Here we just have normal logarithms with numbers. Again, the 8 cancels the log base 8, and we have 1 over 4. We just write 1 over 4. And this is correct as well. What if we have a log without a base? So this is another special case that we want to talk about. So just like x is the same as x power 1, just like x plus 5, for example, is the same as 1x plus 5. These two are exactly the same. This one does not change the value of the equation. We have a special case for logs as well. So log 5 and log base 10, 5 are exactly the same thing. So if we don't have a base, we are allowed to add a base of 10 without changing the value of the equation. So log x base 10 in general is the same as log x without a base. So when we get a log without a base, we're allowed to add a base of 10. So 10 power log base 10, 6. This becomes like any other problem where we can just cancel these out and we get a 6 as a final answer. We have here 6 as a final answer. Let's try some more problems just to make sure that we get this quite well. Again, this is the case where we don't have a base, so we can introduce our own base of 10, and these would cancel out, and we would get 1 over 5. Let's move to another problem in the same exercise. We have 2 power log base 2, so we can cancel these out, and we would get 3 over 2. One final problem. Here we have e power ln 3, so we have e power log base e 3. So remember that ln 3 becomes log base e 3, and we can just cancel these out, and we would get 3 as a final answer. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.